Hey everyone, welcome back to the channel. Today, we're exploring the prototype design pattern in Python, a handy pattern that allows you to create new objects by copying existing ones without the headache of modifying the original. If you're dealing with complex objects and need a quick way to duplicate them, this pattern is just what you need. I'll walk you through the concept step by step and show you how to implement it in Python. Let's jump right in. 1. Introduction. The prototype design pattern focuses on creating new objects by duplicating an existing one, known as the prototype, rather than building a new instance from scratch. This method reduces the overhead of object creation, especially when the initialization process is complex or resources expensive. By cloning an object, you maintain flexibility while minimizing the costs associated with creating new instances. This approach ensures that you can generate objects efficiently while preserving the characteristics of the original prototype. Key characteristics. The prototype design pattern centers on object cloning, where instead of constructing new objects, you create a copy of an existing one, saving time and resources. This pattern significantly reduces overhead by reusing an already initialized object, avoiding the complexity of rebuilding it from scratch. After cloning, it also allows for customization, enabling you to modify the cloned object without impacting the original, offering both efficiency and flexibility in object creation. 2. What is the prototype design pattern? The prototype design pattern focuses on cloning existing objects to create new ones, avoiding the need to build them from scratch. Rather than going through a lengthy construction process, you copy a pre-configured prototype, making object creation faster and more efficient, especially when the objects are resource intensive or complex to set up. This approach ensures you can quickly generate multiple similar objects without repeating the initialization logic each time. Real world analogy. Think of a cookie cutter. Once you have a shaped cookie dough, you can easily make more cookies with the same shape by stamping out copies. Similarly, in software, the prototype design pattern lets you clone an existing object, the prototype, to create new ones without repeating the entire creation process. It's a quick and efficient way to reuse and replicate pre-configured objects. 3. Why use the prototype design pattern? The prototype design pattern is ideal when object creation is expensive or complex and you need to reuse an existing object as a template. By cloning an object instead of creating it from scratch, the pattern boosts efficiency and reduces overhead. It's particularly helpful when you need multiple instances of an object or when creating new ones from scratch would slow down the system. You can still customize the cloned objects, ensuring they meet specific needs while maintaining consistency with the original. This pattern is perfect for improving performance and streamlining object creation. 4. How to implement the prototype design pattern in Python. To implement the prototype design pattern in Python, you create a prototype class that includes a method for cloning or copying the existing object. This method allows you to duplicate the object state without going through the entire creation process. Instead of building a new instance from scratch, the prototype is cloned, saving time and resources. The clone can then be customized without altering the original object, giving you a flexible and efficient way to create multiple instances of complex objects. This approach helps simplify object creation while maintaining performance. Step by step implementation. In this example, the prototype design pattern is used to create objects by cloning existing instances rather than creating new instances from scratch. This pattern is especially useful when the cost of creating an object is high or when instances need to be created quickly, often with slight modifications. By cloning an existing object, we save both time and resources. The prototype class serves as the base class, providing a clone method that returns a deep copy of the object using Python's copy.deepcopy. This ensures that all nested objects within the prototype are also copied, avoiding shared references between the original and cloned objects. The deep copy ensures complete duplication, making the cloned object independent of the original. Two concrete subclasses, concrete prototype and concrete prototype, extend the prototype class. Each of these subclasses has an initializer underscore underscore init to accept a value and an underscore underscore astr method to return a string representation of the object. The subclasses represent two different types of objects that can be cloned via the clone method inherited from the prototype base class. In the usage example, we create instances of both concrete prototype A and concrete prototype B with initial values of 10 and 20 respectively. We then clone these objects using the clone method, producing exact copies of the original instances. The cloned objects retain the same values as the originals as demonstrated by the output, which shows that clone underscore A and clone underscore B have values of 10 and 20, just like their prototypes. This example showcases how the prototype pattern allows for efficient object creation. Instead of building new objects from scratch, which might involve complex initialization, the pattern facilitates the duplication of existing objects. And no, this approach can be especially useful in scenarios where object creation is resource intensive or when we need to maintain the same state or configuration across multiple instances. Referring to earlier responses, this pattern, like the builder pattern, also promotes modularity and flexibility in object creation, allowing for easier maintenance and expansion in complex systems. 5. Real world use case factory pattern in action. 1. Game development character cloning. In game development, the prototype pattern allows developers to clone existing character objects, which is useful when creating multiple characters with similar attributes such as health, abilities, or appearance. Instead of creating each character from scratch, which can be computationally expensive, developers can duplicate a prototype character and then customize its attributes. This method saves time and resources, especially when characters share many common traits, while still allowing for easy modifications to each cloned instance without affecting the original character. Why prototype? The prototype pattern helps in cloning characters with similar properties much faster than creating each one from scratch. It minimizes the overhead of resource intensive operations like loading textures or initializing physics models, making the process more efficient. This pattern also allows you to create multiple character variations with minor changes without repeating the object creation logic, ensuring flexibility while keeping the codebase clean and easy to maintain. Expanded use case. In a game system, players or AI enemies may require characters with different health levels and abilities. The prototype pattern helps by allowing a base character to be cloned and adjusted for various scenarios. For example, if a new character type like an armored enemy is needed, the game can quickly adapt with minimal updates. The flexibility of the prototype pattern ensures that the character creation logic can easily extend without repeating the entire process, making game updates smooth and efficient. Practical implementation. In this example, the prototype design pattern is used to create multiple objects characters by cloning an existing base object which serves as a prototype. As seen in previous examples, the prototype pattern allows for the efficient creation of new objects that are based on a pre-existing object, while still allowing for modifications. This approach is particularly useful when object creation is complex or resource intensive, or when you need to generate many similar objects with slight variations. The character class represents a basic character in a game with attributes like health, abilities, and appearance. The clone method in the character class uses Python's copy.deepcopy to create a full duplicate of the original object, ensuring that nested objects like lists are also copied without sharing references. This means that when the cloned object is modified, it doesn't affect the original object, allowing both objects to maintain their independent states. In this scenario, a base underscore character object is created as a prototype. The base character has a health value of 100, basic abilities such as run and jump, and an appearance of a warrior. This base character serves as the foundation for creating other characters in the game like the player character and the enemy character. By cloning the base character, the player underscore character is given a higher health value 150 and an additional ability attack. Similarly, the enemy underscore character is created with a lower health value 80 and a different appearance of. The key advantage of this pattern is that it enables rapid creation of new objects by leveraging an existing object as a template. Rather than recreating each character from scratch, the prototype is cloned and then slightly modified to fit the new context, e.g., changing health, abilities, or appearance. This not only simplifies object creation but also ensures consistency as all derived objects start from the same prototype. The prototype pattern, as seen here, helps save time and effort when managing similar objects and is an excellent solution when dealing with a large number of related instances that need minor differences. This aligns with the examples we've discussed earlier, where this pattern promotes efficiency, modularity, and flexibility in object creation. 2. Document management system cloning templates. In a document management system, users frequently create new documents from existing templates like invoices or contracts. The prototype pattern simplifies this by allowing these templates to be cloned and populated with user specific information. Instead of creating each document from scratch, the system clones a template, making it easy to customize with unique data while keeping the format consistent. This approach streamlines the process, saving time and ensuring efficiency in document creation. Why prototype? The prototype pattern is useful because document templates already have a defined structure, making cloning ideal for quickly generating new documents with minor changes. It eliminates the need to repeatedly create new objects and manually set up common sections, saving time and effort. By cloning well defined templates, the system ensures consistency across documents while allowing for easy customization with user specific data. Expanded use case. Imagine a company that generates invoices with different customer details like name, address, and amount. By using the prototype pattern, a base invoice template can be cloned and modified to include each customer's specific information. This approach simplifies the process as when a new invoice type, such as an international shipping invoice, is required, the system can be updated with minimal effort. The prototype pattern allows for easy customization and extension of the invoice creation process without duplicating the logic each time. Practical implementation. In this example, the prototype design pattern is used to efficiently create and customize documents by cloning an existing template. As seen in earlier examples, the prototype pattern is ideal when you need to generate multiple objects with similar structures but slight variations. By cloning a pre-existing object, in this case an invoice template, you avoid the complexity and effort of recreating the object from scratch each time. This pattern helps in situations where object creation is resource intensive or when many objects with similar attributes need to be created quickly. Here the document class represents a base document with two attributes, title and content. The clone method uses Python's copy.deepcopy to ensure that a new independent copy of the document is created. This deep copy guarantees that any changes made to the cloned document won't affect the original object, which is crucial when using a template. In this example, an invoice underscore template is created as the base document. The template contains placeholders for the company's name, date, amount, and customer details. Instead of manually creating a new invoice for every customer, the invoice underscore template is cloned using the clone method. The cloned invoice is then customized by replacing the placeholders with specific information such as the date, amount, and customer name for John Deere. This approach demonstrates the efficiency of the prototype pattern. By starting with a base template, we can easily create many instances, e.g., customer invoices, while keeping the original template intact. This saves time and reduces errors by using a predefined structure. The cloned object can be modified without affecting the template, ensuring flexibility and independence between each instance. This pattern, as discussed in earlier responses, is especially useful in scenarios like document generation, where the same basic structure is needed repeatedly with minor variations. By leveraging the prototype design pattern, the process becomes more streamlined, maintainable, and scalable. 3. Graphic design software copying and cloning objects. In graphic design software, users often need to copy and paste objects like shapes or text blocks. The prototype pattern allows the software to clone these graphical objects quickly and efficiently, ensuring that users can duplicate elements without recreating them from scratch. By using this pattern, the system saves time and maintains consistency, making it easy to replicate and modify design elements as needed without affecting the original objects. Why prototype? Cloning complex graphical elements using the prototype pattern is much faster than recreating each object from scratch. It ensures consistency in properties like size, color, and position when duplicating objects providing a smooth experience for users. This approach allows seamless copying and pasting of design elements, making it easier to work with multiple instances without manually configuring each one. Expanded use case. Imagine a design tool like Adobe Illustrator or Figma, where designers frequently need to duplicate shapes with minor tweaks. The prototype pattern enables a base group of shapes to be cloned and adjusted quickly for different design scenarios. If a new design element like a textured background is added, the tool can easily accommodate this with minimal changes. The prototype pattern ensures that designers don't have to redefine each shape's properties from scratch, allowing for efficient and flexible design updates. Practical implementation. In this example, the prototype design pattern is applied to graphical objects such as shapes to efficiently create and modify objects based on an existing template, as referenced in earlier explanations. The prototype pattern allows for creating new objects by cloning an existing object, the prototype, instead of building a new instance from scratch. This is particularly useful in scenarios where objects have similar attributes but need small adjustments, such as changing the color or size of a shape. The graphic object class in this example defines a basic graphical object with attributes like shape, color, and size. The clone method, which leverages Python's copy.deepcopy, allows for a complete copy of the object, ensuring that the clone is independent of the original object. Any modifications made to the cloned object will not affect the original prototype. This is crucial in maintaining the integrity of the prototype while still allowing flexibility in the creation of new objects. Here a circle object is created as the base shape with the attributes circle, red, and medium. By cloning the circle, we create a new shape cloned underscore circle, which can then be modified independently. In this case, the color of the cloned object is changed to blue, demonstrating how the clone can be adjusted without altering the original shape. Both the original and the cloned objects are then displayed, showcasing the difference in color between the two while retaining their shape and size. This pattern is ideal when working with graphical objects in scenarios such as graphic design applications or gaming, where many similar objects like shapes or game entities need to be generated quickly and efficiently. The prototype pattern enables this by using a template prototype that can be cloned and modified as needed, saving time and ensuring consistency. Referring to previous examples, this pattern highlights the efficiency of object creation, the independence of cloned objects, and the flexibility in customizing these objects. It demonstrates how the prototype design pattern simplifies the process of generating multiple variations of a base object, leading to cleaner, more maintainable, and scalable code. 4. Network communication cloning protocol buffers or messages. In network communication, particularly in distributed systems or microservices, messages like protocol buffers or JAN are commonly used to exchange data between services. The prototype pattern allows these message objects to be cloned and slightly modified as needed, making the process more efficient. Instead of recreating message objects from scratch, the pattern enables a base message to be copied and updated with new data, reducing overhead. This ensures flexibility when sending messages with similar structures but different content, improving the speed and consistency of communication between services. Why prototype? Then messages with a similar structure are often sent repeatedly, and cloning them saves time by avoiding the need to construct each message from scratch. The prototype pattern ensures consistency by using established message formats, only requiring small modifications to specific fields. This approach also conserves bandwidth and reduces serialization overhead as message objects are used efficiently instead of redefining them every time. Expanded use case. Imagine a microservice architecture where services handle events like user curated with slight differences in how they process data. The prototype pattern allows a base message object to be cloned and modified for each service, ensuring efficient message handling. For instance, when a new service, such as a reward system, is introduced, the message creation logic can be extended with minimal effort. This approach avoids duplicating the entire process, making the system flexible and scalable for future updates. Practical implementation. In this example, the prototype design pattern is applied to the creation and modification of message objects. This pattern is highly useful when you need to create multiple objects that share the same structure but require slight modifications. As mentioned in previous examples, the prototype pattern allows you to clone an existing object, the prototype, and then customize the clone without affecting the original. This can significantly simplify object creation in systems where creating objects from scratch may be time consuming or resource intensive. Here, the message class represents a basic message with attributes like message underscore type, user underscore id, and data. The clone method, powered by Python's copy.deepcopy, ensures that a full independent copy of the message is created. This deep copy is crucial as it ensures that the cloned object can be modified without any impact on the original prototype. This is especially important in systems that need to send messages to different services or components with slight variations. In this scenario, a base underscore message is created with the message type user created and associated user details such as the name, shell, and email address. This serves as a template or prototype for other messages. The base message is then cloned using the clone method to create a cloned underscore message, which is customized for a specific use case, in this case, the billing service. The clone message's email address is updated to reflect the needs of the billing service while the original message remains unchanged. Both the original and cloned messages are displayed, showing how the cloned message can be tailored for different purposes. This pattern is ideal for systems where messages or similar objects are frequently used but with minor changes. For example, in a system where user data needs to be sent to multiple services like billing, support, or notifications, each message can be cloned from a base template and customized as needed. This avoids the need to recreate messages from scratch, leading to more efficient and maintainable code. By referring to earlier responses, we can see how the prototype design pattern promotes usability, flexibility, and independence of objects, making it a powerful tool for managing repetitive object creation. 5. Content management system duplicating web pages. In a content management system, CMS, administrators often need to duplicate web pages or blog posts with similar layouts and structures. The prototype pattern simplifies this process by allowing content objects to be cloned efficiently. Instead of recreating each page from scratch, a pre-designed layout can be copied and customized with specific content. This reduces time and ensures consistency across pages, making it easier to manage updates or changes to the site. By leveraging the prototype pattern, administrators can quickly create variations of pages with minimal effort. Why prototype? The prototype pattern allows duplicating web pages with similar designs and layouts, saving time compared to building new pages from scratch. It ensures that common layouts are reused, improving the website's consistency. By cloning existing pages, content administrators can quickly make minor adjustments, facilitating content management without needing to recreate the entire page structure. Expanded use case. Imagine a CMS platform where users often create blog posts with a similar format and layout. By using the prototype pattern, an existing post can be cloned, allowing the core structure to remain intact while the user focuses on updating content like text and images. If a new post style, such as a video-based format, is introduced, the system can be updated with minimal changes. The prototype pattern ensures that content creation stays efficient and streamlined, with no need to recreate the structure from scratch. Practical implementation. In this example, we apply the prototype design pattern to web pages, allowing us to efficiently create new web pages by cloning an existing page template and then customizing the clone. As seen in earlier examples, the prototype pattern provides a method for duplicating objects based on an existing template, making it ideal when you need to create similar objects with slight variations. This is particularly useful when building applications where creating new objects from scratch would be repetitive and time consuming. The web page class defines a basic web page with attributes such as title, content, and layout. The clone method is central to this pattern, utilizing Python's copy.deepcopy to create an independent copy of the object. This ensures that any changes made to the cloned object don't affect the original object, preserving the integrity of the base template while allowing flexibility in the customization of the clone. In this scenario, a base underscore page object serves as the prototype, representing a generic blog post with a title, default content, and layout. By cloning this base object, we create a cloned underscore page, which is then modified with a new title and updated content. The deep copy ensures that the changes to the cloned underscore page, such as changing the title to new blog post and modifying the content, don't affect the original base underscore page. This approach is highly efficient when managing web pages in a content management system or blog where pages often share the same layout but create different content. Instead of creating a new page from scratch for each post, the base template can be cloned and quickly customized for different purposes. This not only reduces development time but also ensures consistency across pages. The prototype design pattern, as discussed in previous examples, emphasizes the reuse of a predefined template, allowing for easy and independent modification of cloned objects. This pattern is particularly useful in maintaining flexibility and scalability, especially when dealing with repetitive tasks like page creation in web development. And that's it for the prototype design pattern. Now, you know how to clone objects efficiently in Python without messing up the originals. If you found this video helpful, be sure to hit that like button and don't forget to subscribe for more tutorials on Python and design patterns. Thanks so much for watching, and I'll catch you in the next one.